Okay. All right, so we're going to do a review of quiz 3 real quick. And then we will do a review of the quiz you just took. And then we will go into lecture. So let's take a quick look here. This is from quiz 3, which was about functions, closures, collections, and the like. So here's a question about functions. Basically, it's a question about definitions. So this is, match the function definition element with the correct terminology. So basically, which part of, what is, this part? What is the arithmetic key word here in the function? What is that? And the answer is that's the identifier. When you use an underscore, when you're defining a parameter, then that is an omitted argument label. So that's that. This LHS right here is an argument label, which we covered with the lecture on functions. RHS I meant, not LHS, which is this right here, argument label. LHS string, which you'll note there's a space between your argument label and your parameter, is the parameter name. And then this little arrow guy is the return indicator. It is the kind of special character or set of characters that Swift uses to say, hey, we're done defining the parameters, and this is the return type after this. The next question was about which of the following lines is the correct way to call the function. This relates directly to what the argument labels are about. One thing that we went over in lecture was that when there is no argument label provided, you use the parameter name as the default argument label. When there is an argument label defined, then you use that argument label when calling the function. And when you omit an argument label using underscore, you do not need to use, or you do not provide an argument label. You just put in the value that you're passing to the function. So in this case, there's only one correct way to call the function, and that is by using the argument labels as they are defined, which is LHS, RHS, and then this underscore means that there is no argument label, so you do not provide one when you are passing in the operation string. So here we have the argument 5 in quotes, the string 5, and we pass that as an argument to LHS. And then that means that in this function, the LHS string parameter has the value 5 when we're calling it like this. Same thing with RHS and this. And then for our last parameter, because we've omitted the argument label, there is no label. You just pass in the value directly. Cool. Okay. Question 3, what does the following code print to the terminal? This has got to do with closures and the order that closures operate in. Essentially, when you call the addition function, like so, and pass in 10 and 5.1, what will happen is you will enter the function. You will hit the first line where you print LHS, which is the parameter 10.0. So 10.0, very first thing that gets printed. So this is right out, which means all of the above is right out. Oh, and this one too. And that's because LHS is a double, and so it retains that 0.0. Then you go to the closure, and the closure was passed in to this function using a trailing closure, where if you put a closure at the very end of your parameter list, then you can pass it in using this syntax. We covered that during lecture as well. Once you use that syntax, basically, this is basically calling this block here as a function. And I should be using my mouse, not my finger. So this closure here calls this as a function. This is the parameter, and the parameter being the data being passed in is LHS plus RHS, which in this case would be 15.1 because these are doubles. So we know 10.0, 15.1, and that is the only one with those. And then just to verify, the very last thing that we print is the 5.1 that was passed in. We come back in here after we run this function, the closure that was passed in, and then we come back and we do this. So that's how the execution flow works. That's how you get this. Okay, this one is about strings, string literals. String literals that have the, that use 3 quotes. This is kind of covered in the reading a little bit. We didn't really talk about it in lecture at all. It's you know, one of those questions that's kind of mean. So this is one of those questions where I'm like, this is why I'm doing a curve for these quizzes, because sometimes I write mean questions. So apologies. So here, basically, when you have these quotes, 3 quotes and then 3 quotes to close, Swift requires that those be on their own lines, and then it prints everything in between those 2 that are not on the same line. So it just ignores everything on this line after and everything before on this line. Everything within gets printed with the exact same spacing and formatting that you provide in that block, except for the leading white space gets dropped so that you can have proper indentation. So in this case, we would print 6 with a plus, and then 7, and then a colon, and then a new line, and then 6 plus 7, which is 13. And so that's why that's the answer. Okay, what is the following code doing? So basically in this code, we have a for loop. It goes through the string A, B, C, D, E, F, G. We talked about in lecture using this enumerated function call on any type of collection. It will return you an iterator, which in a for loop basically allows you to create a, instead of a regular variable, you can create a tuple that has an index for the first value and the value of the collection for the second. So this way you can kind of get that same sort of, I that you have in for loops in other languages. So then here we just kind of look at the end index of S1. We just get that, whatever it is. We offset it. We create this offset constant where we say -I minus 1. So to start with, if we think about it line by, piece by piece, our very first iteration here, I is 0, C is A. It's the character A. Okay, so -0 minus 1 is -1. So then here we do S1.index end offset by offset. This is just kind of Swift's weird way when you're doing string modification to basically say, hey, starting from the end, go back, or starting from a given index, make this change, make this offset. So here we're saying start at the end of the final index and offset it by -1, which means go back 1. And then we go to S2, which is this empty string, and we add the character at that index. So the end index -1 is going to be G in the string, because the end index of a collection is always 1 beyond the end. So it's 0, 1, 2, 3, 4, 5, 6, and then end index would be 7. So if you go through again, this will be -1 minus 1, which is -2, then, which, resolves to being the index here of F, right? -2 minus 1 is -3, which then gives you E, so on and so forth. So what's being done here is we are reversing this string, character by character, and appending it into S2. So we are printing a reversal of the S1 string. Cool. All right, the following code has an error. Where is it? What is it? And how would you fix it? So this has 3 pieces to it that all need to be correct. The first piece is where is the error? And our error is in the print statement within the print statement. The issue is that we are attempting to access a dictionary's values by passing in an int for the key, but this particular dictionary has strings for its keys. So in order to actually correctly access what we want, which is the age of Mary, if we use context from the print, then we need to be passing in the correct key, and in a dictionary, when you define it with a dictionary literal, the key is the thing on the left and the value is the thing on the right. So Mary is the key and the value is 24. That's because Mary's age is 24, right? So in order to fix this, we change 24 to Mary. Okay. Which of these statements about optionals is true? Optionals can be nil, non-optionals cannot. That is the fundamental truth about optionals. They are the only things that can be nil in Swift. Anything that's not optional cannot be nil. When an optional is unwrapped, the result is non-optional. This is generally true. There are weird edge cases where it's technically not. Again, I curve for a reason because I realized that afterwards that I'm like, I guess there are cases where that's not true. But most of the time when you unwrap an optional, your result is non-optional. What you get out of it is non-optional. And then optionals can wrap other optionals. Basically, you can put an optional around an optional around an optional and kind of nest them, and that is true. So you get all of the above. Okay. Consider the following function definition. We want to call the function and print the square of the returned value. Which of the following is a way to do that which compiles correctly? So for this function, we want to call it, and then we want to print out what we get. So this has to do with both calling and unwrapping optionals. So here, our function has a return type of int question mark, which means it is an optional int, which means it could maybe be nil. We don't know. One thing that we went over in lecture was that when you get an optional, you cannot perform operations on that optional as if it was its underlying type. You have to unwrap it first. And so any of these options that does not attempt to unwrap the optional is incorrect. So print pow has value 2, that's incorrect. Let value equals has value, value times value, that's incorrect, right? Neither of these is even attempting to unwrap the optional and get access to the int within. This first option here, if let value equals has value, this is one of the main ways that you unwrap optionals is you use if let, and then when you're within the block for the if let, you have access to that constant that you unwrapped into, and it is guaranteed to be the non-optional type of the optional, in this case, int. So we can multiply value by value, and then we'll print the correct thing. Here is one of the other main ways that we unwrap optionals, where we use what is called the nil coalescing operator, the double question mark. Basically, anything to the left of nil coalescing, if it is optional, then we are saying, okay, if this is nil, then just use whatever's to the right. So in this case, if value comes back as nil, then we just put the value 0 into the value constant, and then 0 times 0 is 0. This is a way to do this correctly. It does mean you'll print 0, but basically you're not going to crash or fail to compile, which is what these would do. Here is a guard let. This also would fail to compile. This is almost correct. It has the key fundamental misunderstanding that within the block of the guard let, you do not have access to the constant that's defined. You have access to the constant that's defined after the block of the guard let. It's kind of the opposite of if let. If let, you have access within the block. Guard let, you have access after the block. And then within the block, you have to perform some sort of early exit, be it breaking out of a loop or returning from a function. Okay, this one, arranging the following lines to be syntactically correct for handling errors from calling the division function. So I basically took a simple function call with an error catch and put it into this format. I did not do correct indentation on this one. I did do correct indentation for the one today, thinking that might help a bit. But here, basically, when you're doing a error catch, you need to, you do, then you attempt whatever it is that you're trying to attempt, and you use the try keyword. Then after that, you catch, and you can put that into an error constant that you can then use within the catch block. Then you typically will want to cast that error to the correct kind of error that you're looking to use. So in this case, error as question mark arithmetic error. And then we have a comma here, which indicates that this if-let is not done. If-lets can chain multiple unwraps, one after the other, or multiple, not just unwraps, but also Boolean expressions, one after the other. And it does so with a comma. It's very similar to ampersand in your standard Boolean expression. So here we check, okay, so first we unwrap the error and say, okay, is this an arithmetic error? And if it is, then we say cannot divide by 0. After that, we then print the error. Hey, we're not allowed to divide by 0 if it is a cannot divide by 0 error. And then otherwise, we print out there was an unknown error. And then at the end, we have to close the catch block, which is what we're doing here. Yeah, it would be easier and clearer with indentation, I think. So moving forward, those types of questions will have indentation. This one, considering the following function. So we've created a function here that performs division. It throws an arithmetic error. This is basically the function that's being referred to here. Honestly, it might have been smarter to do this question before this one. Like I should have ordered them differently, but that's that. So we have this division function where we have a left-hand side string and a right-hand side string that get passed in. We basically attempt to turn those strings into doubles, and then we throw an error if we can't. And then after turning them into doubles, if the right-hand side string or the right-hand side argument of the division is a 0, we throw an error, cannot divide by 0, because if we tried to do that, we would get like not a number as the response, or infinity or something like that, which is not correct. And then after all of that, we actually perform the division and return the result. So, which of the following catch blocks properly handles errors thrown by the above function? This first one is not syntactically correct. If you are going to be defining a constant after your catch, you need to use the let keyword. Also, you can't just throw from within catch. If you wanted to do that, you just wouldn't bother having a do try catch block at all. You would just try and then have whatever function you're doing that in throw. And that would propagate the error forward. Here, you can do a switch on an error. Error is not defined after the catch block, and that's okay. By default, you get one called error. Swift just gives you one. You can change the name of it if you want by doing catch, let, and then a variable name or a constant name, but you can just use a default one like this. This one will also work. You can basically catch specific enum cases for your errors. This was one of the things we covered in the lecture as well. And because this works specifically because we know that division specifically throws an arithmetic error. So the type of the error is known. It's known that we have an arithmetic error coming out of the function, so we can catch specific cases of the arithmetic error. And then here we have catch let error. This is that thing where you could rename it if you wanted, but in this case we didn't. We just said error just to be more clear. We say if error is cannot divide by 0, or if error equals failed to cast. So again, very similar to catching the different enum cases here, except here we're using a set of if blocks to do that. And then last but not least here, this is kind of gibberish. Basically, this parentheses around error, or around quotient after error, isn't a thing syntactically in Swift. It kind of, in a way, it can be for some types of enums, but it's not here. And then also, when you check the case of the error, you definitely aren't checking quotient. You would be checking error itself. Okay, so that's the Class 3 quiz. Did anyone have questions about any of those questions and answers before we move on to today's quiz, Class 4? Cool. Okay, so Class 4 quiz. Boop. All right, so the very first one here, this is basically, did you see the section headers of the slides at lecture last class? Classes are reference types, enums and structs are value types, and values pass by copy and references pass by reference. Here we have an extension on a class called user, and then a function called username that is being added to that class. I say class. It's a type, as far as we know. So we can't tell from this if it's a class or a struct. So the first question, what is the if statement checking for? So that's this if self is premium user, okay? So this is checking the type of self, and self is referring to the instance that is calling this method. So whichever object, whichever instance of user is calling this method, is trying to see, okay, I'm a user, am I also a premium user? So basically what we are saying is if the instance this function was called by is of type premium user. Other options, if this function exists for the user subclass premium user, this function exists for any class or subclass of user because it is an extension on user, so we're not checking that. If the function type of the username function is the same as the premium user type, this one's actually a pretty good guess, just because self could be referring to the function instead of the type, the kind of extension type. However, that is not the case. Self always refers to either a class or a struct, but like whatever custom type you're defining, it never refers to a function. And then if the self keyword is currently not nil, if we were doing that, we'd do something like if let myself equals self, right? We'd unwrap it. Or we'd say self equals nil, or not equal nil. Those are valid ways to check for nil. Checking to see if you are a particular type is not how you check for nil. Okay, assuming there are no warnings or compiler errors, what can we infer about the user type from this extension? Okay, so here we say we see it has a property called name that is of type string. Okay, so let's see here. Where's name? Here it is, self.name. Well, we know that self is referring to our user type, so self.name implies that there is a property called name on there. It is a class type. Okay, this one, let's see. In order to determine if this is a class type, we need to kind of consider, okay, so we know that this is a user type, and then we also know that it's possible for us to be a premium user type as well, which indicates that we have the possibility for inheritance, where premium user is a subclass of the superclass user. which means that it's a class type because inheritance like that does not exist for structs or enums. And then it has a subclass named premium user. Well, yeah, that's a part of figuring out it was a class type. And so we say all of the above. Cool. Any questions about this code block and these questions before we move on? Okay. All right, so for this question, consider this code for the questions to the right. Here we've created a struct called product. It has a nested enum called category. It has a number of properties and a function. So we receive an error on line 12, price equals price times percentage. Cannot assign to property, self is immutable. Why is this happening and how would you fix it? Well, as soon as we see immutability, and as soon as we see that we're dealing with a struct, we might think, right, structs are sort of intended to be immutable by default. There is a special keyword that we need to use if we are trying to have a function within a struct mutate itself, change any of its properties, change any of its own properties, and that is the mutating keyword. So our first answer here, struct properties are immutable in struct functions by default. So any functions that are within a struct, the properties are considered to be immutable by default unless we give it a keyword that says otherwise. Fix this by adding the mutating keyword at the start of the function definition. Let's assume, and I'm going to stop going through all the other answers as well, just because we don't have a lot of time and we have a lot to get to today. So let's assume we want to modify the stored property, okay, named category, okay, to be a collection of category cases. So instead of holding a single category case, which is what it currently does, it could currently hold electronics or clothing or books. We want to make a change so that it could hold many different categories. It could be electronics and clothing and books or so on. The best way to do that is with a set. We talked about this as a thing that is a common use case for enums in Swift, where you create categories, not categories, where you do configuration by using different enum cases within a set, and then you can just check to see if those cases are within that set. We use a set instead of an array just because it doesn't make sense to have the electronics category twice. You can't be electronics 2 times. So we use a set instead, which guarantees uniqueness and distinctness of the members or of the elements within the collection. All right, here we have this large class called user, and this is the class we were kind of referring to before. Which of the functions defined in user would be appropriate to change to a computed property and why? So of all of these, only one of these is appropriate to change to a computed property. If you'll recall, computed properties are essentially, they're similar to stored properties, except they are also similar to functions in that they have a block of code that executes when you call them, rather than storing a value within them. But you can't pass any parameters to a computed function, or a computed property. So the only kinds of functions that would be appropriate to turn into computed properties are functions that have no parameters. Otherwise, remove product, we couldn't really write this as a computed property. There's no way for us to pass the ID in. Same thing with add to cart. Computed properties are they're intended to be something you can calculate on the fly rather than something that you store things in. You can use setters with computed properties to set something as well, but adding things is just not, like adding things to other whatnots and removing things is just not something you would really do with a computed property, because they are also expected to have a return as well. So number 7 here, consider this code that is using the class. What would we expect this code to print? So here we create an instance of user, of the user class, and we call it, very creatively, we call it user. Then here we access the property name on user, okay? And this is the property name, awesome. Now name has already been set to Scotty in our initializer, right? Self.name equals name, and name was passed in here. So we passed in the name Scotty. So right now user.name is Scotty. However, then here we say user.name equals Amy. So we change it by assigning a new value to the property, to the stored property, and then we can print it and it will print out Amy. All right, now let's say we want to create a new function for user called by now. It will add new product to the cart, remove old products from the cart, and return the new total resulting from those changes. Organize the code blocks below code blocks to accomplish this correctly. So first thing to note, your indentation will help you out here. We open out with our function definition. We close with the closing bracket. For the key kind of thing here, we're going to have for product in cart, remove product by product.id. This product here is overriding this product here, which means product.id refers to the ID of the product that we are iterating across in the cart, and cart is a collection right here that we see. It's an array. So we iterate through the cart and we remove all of the products as we go. And then here we can add to cart. And the reason we add to cart after we remove everything from the cart is because if we did it before, then we would remove what we added. So it defeats the purpose. And then after that, we return the cart total and we calculate the new total for the cart, which is just going to be the price of this single product. But, it's a silly function, but it is one that exists. It is one of the functions you could write. Any questions about classes and the questions here? Questions 6, 7, and 8. All right. So now, what is a class instance? This comes back again to definitions of kind of concepts. A class instance, an instance is a kind of block of memory that is in the shape of your class type that can be referred to from many different properties or constants or variables throughout your code. And they can all share a reference to the same piece of memory and write to it and read from it. And that can cause problems, but that's what they are. So when we look through this, we can see our correct answer is a class instance is a shared allocation of memory that multiple different scopes can modify. So we can modify it from different scopes in our code. All right, and then which of the following statements about class inheritance is true in Swift? When code expects a superclass type, a subclass instance may be used instead. In the below example, the constant of type A, let instance A, now points to an instance of type B because we instantiate a B right here. This is the correct answer. It is the truth. Everything else is either kind of like the opposite of true or like something that just doesn't make sense. Or not something that doesn't make sense, but something that is just not true in any way. Yes, so this has to do with inheritance. We know that any property, any constant or variable of a superclass type can actually be pointing to an instance of the subclass type. So that is this quiz. We're going to do a quick 5-minute break before we dive into lecture because this took a while, and then we will dive into lecture. So I'm going to see if I can find a timer thing, but let's just go ahead and say we'll meet back up at 1:19. That's when we'll start.